Hello and welcome to another video here on this channel. It's been quite a bit of time, but we're putting on a new series now where we're going to be talking about math. Yes, math. So there's a couple of chapters around 10 to 15, maybe more. We'll see how well this series goes that people have problems with in grades 7, 8, 9, and 10, like it's stated there. And this is a new series where we're going to be touching and solving questions on different math topics. In this case, the first chapter is number systems. So we're going to be talking about number systems. We're going to be solving questions of number systems. There'll be some homework questions which we want you to try or attempt. And if you have any doubts, even any doubts, anything at all, just please write it on the comments and we'll surely help you. So now, let's begin. The first question, which is find three rational numbers between 1 over 3 and 1 over 5. So first let's write these numbers down. Sorry. And 1 over 5. Yes. Now we've written them down. Now, firstly, without doing anything at all, I can already see between, right? It says between. So when you find three rational numbers between these, I can already see, and I'm pretty sure you can also see that 1 by 4 is between. Why? I'll explain. We know the number sequence goes 1, 2, 3, 4, 5. Yes? So we can see a pattern here, 3, 4, 5 in the denominator. So 3, 4, 5, that's why 4 is in between of 3 and 5. So that's why we can say 1 by 4 is a rational number in between of 1 by 3 and 1 by 5. But sadly, this is only 1. So we write 1 by 4 in this box as in to represent that we found one rational number, but we have to find two more. But how would we do that? So we keep 1 by 3 here, and we also have 1 by 5. Let's make the denominator equal. So how would we do that? Well, what I'd do is I'd multiply this by 5, and then if we're multiplying this by 5, we multiply this by 5, as in to make this 5 over 15. Yes? And I'd also multiply 1 over 5 by 3 and 1 by 3 then, which would make this 3 over 15. But now we can see that the denominator is the same, yes? So what comes in between of 5 over 15 and 3 over 15? Well, again, as in it was, this time it's in descending order. We know 6, for example, let's say 7 by 15 is here, 6 by 15, 5 by 15, blank by 15, let's just write by 15, and then 3 by 15, 7, 6, 5, 4 by 15. So we know 4 by 15 is also in between of these two numbers. This was just to reference it, but yes, 4 by 15 is also in between of these numbers. So let's write 4 by 15 here. And for the final one, let's just erase this. We had, I think it was 3 over 15. We'd simplified it to 3 over 15, sorry, not 1, 3 over 15 and 5 over 15. Now, let's make the denominator equal again, but let's this time, instead of 15, let's make this 30. So how do 15 times what is 30? We know that's times 2. If we're timesing the bottom by 2, we do it here as well. 15 times 2 is 30 again, then 3 times 2 as well. So that means 6 over 30 and 10 over 30. Yes? Now we need to find numbers in between. So we know 6, 7, then what? 8, then 9 over 30, over 30, yes? Over 30. Now, many people would be like, oh, I'll just pick all three of these, or I'll just pick one of these. But one thing you'd be doing wrong is if you pick 8 over 30. Why? 8 over 30 is the same as 4 over 15. Because if you divide this by 2, it equals 4. If you divide this by 2, 15. And 4 by 15 equals to 4 by 15. So you cannot pick the middle one, which is 8 over 30. So this one is completely wrong. So we erase this off. This one's wrong. And as we know, these two are the reference numbers. So what do we have? 7 over 30, 9 over 30. Let's just write them here. 730, 9 over 30. And what does this show us? This shows us that we found more than 3 rational numbers. They were asking for 3. We found how many? 1, 2, 3, 4. We found 4 rational numbers instead of 3. And there's infinite rational numbers in between of these numbers. It's not that hard, and you can just continue if you wanted to find more. Let's say this was 10 rational numbers. You would just continue multiplying this by even more numbers, maybe 100. This also by 100, 100, and 100. And then you'd find infinite rational numbers. The more you multiply, the more rational numbers you find. Now, let's go to the next question. Okay, this question is asking us to represent 2 by 5 and minus 2 by 5 on the number line. So this point is given to us as a 0, right? So let's say this is point 1, okay? And then if this is point 1 on the plus, and let's have a plus here so that we know that this is a plus side, and then minus side, of course. And then if this is 1, then we know this has to be minus 1, this one. But what's in between of these? So let's say 0. How many are there in total? So there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? There's 5. 5 lines. So what do? We know that the denominators are 5 because of that. All denominators are 5. And also 1's denominator we can also express as 5. And we know 1 is equal to the same. So 5 over 5 is we know equals to 1. So that's fine. But 0, and let's just fill in with numbers. 1, 2, 3, 4. So we've got what? 0, 1 over 5, then 2 over, we've got 0, 1 over 5, then 2 over 5, then 3 over 5, then 4 over 5, and 5 over 5, which is also equal to 1. Yes? Similarly, on the other side, let's put these as 5 as well. But this time it's going to be minus 1, right? Minus 2, minus 3, minus 4, minus 5. And now they're asking us to represent 2 by, sorry, I did 2 by 5 and minus 2 by 5. So where's 2.5? It's here, right? And where's minus 2 by 5? Well, it's here. So we have represented where these are. They're asking us to show where you can see these. So we've represented these two here. So that's the final answer, and that's how you do it. Yeah. Now they're asking us in the third question. This question I'd like you to try by yourself first. You saw the first example. I want you to try this by yourself. What would you do for this question? I'll give you 5 seconds to try this. 1, 2, 3, 4, 5. If you needed more time, then just pause the video and it'll be perfect. But yes, I'm going to solve it now. You can just pause the video if you need to. This time they're asking us 14 over 3, okay, and minus 14 over 3. So this is what? An irregular fraction. And we don't like irregular fractions. Let's just put this, sorry, why is there a line in between? Yep, this is not asking us to minus. This is just example, just do it like this. Okay, and this is actually means multiplication, so forget this. Forget I did that. Yeah, anyway, 14 over 3 and minus 14 over 3. How would we make that? How would we make that mixed? We want mixed this time. So let's say how do we make this? So we know 3, this number. How many times does 3 go in 14? Let's just divide this just to check. So we know 3 goes 12 times into 4, and we get a remainder of 2. And it goes 4 times into 2, and then we know remainder 2. But we also know that 2 over 3, that we can always put this at the bottom. So we have 4, so I'm going to write it down here, 4, 2 over 3. That is what 14 over 3 is equal to. And similarly, minus 4, 2 by 3 would be equal to minus 14 over 3. Agreed? If it is agreed and it makes sense, let's continue to the next step. So actually now let's mark these numbers as 0. Let's mark this as 1, 2, 3, 4, 5. Yes. And then let's mark this negative side as minus 1, minus 2, minus 3, minus 4, and minus 5. Perfect. So let's do the positive side first. Oops, that was a bit of a sloppy line. So sloppy circle. Let's draw that again. Let's do this one first. So we know 4. We needed to find 4 first. So we located 4, which is right here. Yes? Now, for 2 by 3, we need to find 2 by 3 as well. But how do we find 2 by 3 in this area over here? Well, I think we should divide it into 3 separate parts. So here we are. Let's draw this. 1, 2, and for 3 by 3 just basically means, so this is for 1 by 3, for 2 by 3, and for 3 by 3 just means 5. In this example, it just means 5, so we don't need to draw this. And they're asking us to represent 4 2 by 3. So we represent 4 2 by 3 on this extra line here. We just make a circle here, and we found where 4 2 by 3 is. Similarly, on the other side, we just flip it. We make 2 lines here. This is, let's say, what? This is minus 1 by 3. Let's make this minus 2 by 3. And then let's just circle this, as this is equal to 14 by 3 and minus 14 by 3. So this question done. This was a bit of a tricky question. Next, we're going to go on to rationalizing, which is also a part of number systems. Many students, many people have problems with these type of questions, but you don't need to worry. They're not that hard. And if you try your hardest, you will definitely get them. So let's start. How would we rationalize denominators? So let's get this, for example. This is our first question. This is divided into 4 questions. So there's going to be 4 questions into this. A, B, C, and D. But we're going to start with A. So we have to rationalize 4. I'll just write this again, a bit bigger maybe. Yes, like this. 4, and then root 3 here. We got root 3, and we have to rationalize this. This is the question in the textbook or in anything. If this is the question that comes to you, what would you do? So to rationalize a denominator, you need to make the denominator rational. Rational. So we know root 3 is actually irrational. And we know a whole number, like I said in the first question, these are rational numbers. A fraction, 1 by 5 is also a fraction. 4 is a rational number. These are all rational numbers. So we need to make this preferably into a whole number. In this case, we're going to try. But how do we make this into a whole number? Let's see. We would, to make root 3 a whole number, we would have to multiply both sides by root 3 and root 3. But why? You might be asking, why are we doing this? Because what do we know? When you multiply two roots that are the same, root 3 times root 3 equals to 3. Yes? Roots out. They're out. And root 3 is just root 3 times root 3 is just equal to 3. Easy. And while 4 times root 3 is, we cannot write it as root 12 or something like that. We have to write it as 4 root 3. So we rationalized our answer, and our answer came as 4 root 3 over 3. Let's go to the next part, this time B. And in B, after I've written it, I want you to try this question by yourself, and I'll give you 5 seconds. And if you need more time, feel free to pause the video. And I think this is clear enough. What does this equal to? Let's see. I'll give you 5 seconds. 1, 2, 3, 4, 5. Pause the video if you haven't got the answer yet, and if you are stuck, just continue watching the video. We will continue now. So again, root 10. How do we make root 10 a whole number? Well, very simple. We multiply both by root 10. Exactly. So that root 10 times root 10, again, like last time, root 10 times root 10, we know it equals 10. Yes? But root 3 times root 10, now we can write this as root 30. Very simple. So this is the correct answer for B. Let's now hop on to question C. And also try this one. Just try it before you watch the solution. I want you to see if you can do this. This one is a bit more tricky, next step maths, but it shouldn't be too hard. Let's see. So solve this. I'll give you 5 seconds. 1, 2, 3, 4, 5. I'll solve it now. So we already have 3 as a whole number. Yes? So we don't need to rationalize 3. 5 is the real problem. Root 5 is the real problem. But we know how to rationalize root 5. We just need to multiply it by root 5 on both sides. Again, on the top and the bottom. Root 5, root 5. So we know this equals to 2 times root 5 is simple. 2 root 5. And 3 times root 5. Simple, again, 5. And then we can also simplify this further as 2 root 5 over 3 times 5, 15. So this is the answer. If you got this answer, amazing. If you didn't, try again and spot your mistake. That would be the best part. Now let's go to question D, the final one for this section, and then we move on to the 5th question, which is the final question. D. Yes. So this question is a bit more tricky for you guys, but you should still be able to do it, I hope. If it's a bit too hard, continue watching, but I'll give you 5 seconds still to solve this. 1, 2, 3, 4, 5. Let's start. So what we would do on this question is we need to rationalize the denominator again. So we have to multiply by what? Yeah, we have to you guessed it, we have to multiply it by root 2 on both sides, on the top and the bottom. So 3 plus root 2 times root 2, what does that equal? Simple, very, very simple. What does it equal? So, yes, what would you do now? Well, you would have root 2 common up here as you're multiplying it with root 2. And then in the brackets, because we have to multiply this by both of them, we have to have 3 plus root 2. Simple. Very, very easy. And then at the bottom, root 2 times root 2, well, again, very easy. It's 2. And then down here, now we just simplify the brackets. Root 2 times 3, again, 3 root 2, 3 root 2, sorry. And root 2 times root 2, again, very easy. Oh, sorry, not root 2, it's 2, and over 2. This would be the final answer and the correct answer. Now, for the final question. This is another simplify by rationalizing the denominator, but this is more complicated than the other one. This is a lot more complicated. And I want you to pay attention on the first one. You do not have to try to solve this by yourself. If you want to, of course, pause the video and help yourself. But I want you to at least foresee this one. And then the second part, this is also again in 2 parts. The first part, I want you to see what I do. Second part, I want you to try. So the question, I'll just write it here, is 1 over 4 minus root 3. Yes? But how would we make 4 minus root 3 rational? We would multiply it by, well, why? I'm going to show you what I'm multiplying it by. I'm multiplying it by, sorry. Oops. I'm multiplying it by 4 plus root 3 in the same, I'm multiplying it by, I'm multiplying this. Now, why am I multiplying this? Because I want the minus and the plus. This is a minus, by the way. I don't want a minus there right now. I want this to change a bit. So now, let's simplify this now, actually. So what would we do? We would have 1 multiplied by 4 plus root 3, which is the same thing again. 4 plus root 3. Yes. And we would have, so let's actually FOIL method this. So I want to FOIL method this. This is a bit more advanced than the other one, but yes, we do know how to do it. So 4 times 4, what's 4 times 4? Very easy, 16. What's minus 3 root times 4? Again, very easy, minus 4 root 3. Oh no, I made a mistake. Sorry. Let's start from the start. 4 times 4, again 16. Now we have to multiply 4 by root 3. Sorry, my bad. I multiplied this earlier. We have to do this. 4 times root 3, which is 4 root 3. So plus 4 root 3. And then this, minus 3 times 4, which is minus 4 root 3. Let's just write this, minus 4 root 3. And minus root 3 times root 3, which is, you guessed it, minus 3. And what actually happens here is 4 root 3 and minus 4 root 3 cancel. So this is gone. This part, let's just forget about it. Yes? Now at the bottom, what do we have? 16 minus 3. And I'm just going to erase this as in to make more space for the final answer. And this can be simplified a bit by making it 4 plus root 3 over 13. This is the correct answer. I hope you got this one. It might be a bit hard, but yes, this was the answer. Now let's go to question B, right? Just 2 seconds. Let's just clear all this. It's tedious work, but hope you're enjoying the video so far. And this is the time for me to say, go subscribe to the channel, like the video if you haven't already. And while you're at it, I'll give you also 5 seconds to do that, because I'm a very nice guy. We can wait 5 seconds for you. 1, 2, 3, 4, 5. You haven't missed much. We're starting the second question. Now, this question that I'm writing here, I want you to solve already, and then I want you to watch the video and see what you've got as your final answer. So I'll give you 5 seconds for this as well. Again, 5 more seconds. 1, 2, 3, 4, 5. Continuing from where we left off. What do we multiply this by? You might have guessed if this is positive at the bottom, like we did in the last one, we have to multiply it by negative this time. So negative on the top. Sorry, root there as well. Root 2 minus root 5. Perfect. Now, 6. Now let's just first do the numerator part, which is the top part. So we know root 6 into root 2 minus root 5, which is equal to, what's root 6 times root 2? Well, it's root 12. And what's root 6 into root 5? Well, that's also very simple. It's root 30. So this is the correct answer for now. So we've got the numerator. Let's erase this part now, as in to make space. This is where I'm going to write my final answer. I'll just show you in 2 seconds. So the numerator we found is 12 minus root 30. Right? Check. Now, we have to do the bottom part, which is 2 plus root 5, and then multiply root 2 minus root 5. I have enough space. Let's multiply root 2 times root 2, which is root 2 times root 2. Very straightforward. It's 2. Root 2 times minus root 5, which is minus root 10. And then 5 root. Sorry, let's redraw. These arrows are done. Let's draw this arrow now. Now, root 5 times root 2 is equal to root 10, so plus root 10. And root 5 times minus root 5 is equal to minus 5. So let's erase this part now. And I'm pretty sure you can already see the fact that minus root 10 plus root 10 is equal to 0. Cancels. Sorry, this part is also gone. And therefore, we have a bottom of 2 minus 5. And now, we can have this kept as 12 over 30. I'm not simplifying the top because my job is only to simplify this, rationalizing the denominator. So we're going to have minus 3. So the final answer was, I'll just write it again here for clarity, root 12 minus root 30 over 3, which is minus. Easy, very easy. These were the questions. Now for the homework. Okay, I'm nice. I'll give you 2 homework questions. I was thinking of giving 4, but I'll give you 2. One is, both of them are rationalizing, because I think that was the hardest part of the video today. Let's just do that. A, rationalize 1 root 3. Not that hard. Very easy, actually. And now I'll give you 3 questions. And also, the next one is rationalize this. Just give me 2 seconds. And C, find 3 rational numbers. 3 rational numbers between. Okay, what 3 numbers? I'm gonna find random 2 numbers that I think of. 1 over 7 and 1 over 11. Yeah, I think that's fair. And yeah, thanks for watching. Like, share, and subscribe if you haven't already. Share it to your friends. Do everything you want. Hope you enjoyed the first video. And smiley face for you guys who've stayed until the end.